We're doing Gaussian elimination. The previous videos we've looked at examples. We're going to look at 2 more examples in this video, but they're going faster. So if you want me to go through an example slower, please look at the previous videos. All right, so let's take a look. Again, I've got a system with 3 equations and 3 unknowns, and we want to solve the system, and we're going to be using Gauss-Jordan elimination. So I'm going to set up the augmented coefficient matrix 1, 0, 2, 7. Minus 1, minus 1, 1, 3, 2, 1, minus 3, minus 8. All right, our first step is to get our leading 1. We've got the leading 1, so we're skipping our first step. Then we need zeros underneath. So what are we going to do? We're going to leave row 1 as it is, 1, 0, 2, 7. We're going to work with row 2 and row 3. What are we going to do? We're going to add some multiple of row 1 to them, because row 1 has the leading 1. So for row 2, what multiple of row 1 do I need to add? 1, because minus 1 plus 1 gives me 0. And row 3, I need to add the multiple minus 2, because 2 plus minus 2 gives me 0. So let's take a look at what this is going to look like. We will get 0, minus 1, 3, and 10. In the next one, row 3 minus 2 times row 1 will give me 0, 1, minus 3 minus 2 times 2 is minus 3 minus 4 is minus 7, and then minus 8 minus 14 is minus 22. All right, like I said, it's going a little bit faster because we've done a couple of these, so please go to part 3 of the video. I'll link the whole playlist down below in the description, but go to the previous one if you want a slower explanation. All right. Column 1 is done. We've got our leading 1 and our zeros below. Now we need a leading 1 in my second row, second column. Now there's a minus 1. Yet again, we can swap rows around. That doesn't matter. As you can see, there's already a 1 there, but it's not very difficult to change that into a leading 1. I'm going to simply take row 2, and we get a leading 1 by using the row itself, not any other rows. I'm going to multiply it by minus 1. So I've got 1, 0, 2, 7, 0, 1, minus 3, minus 10, 0, 1, minus 7, minus 22. Row 1 and row 3 stays the same. All right, now I've got my leading 1 here. I need a 0 below it and above it. I've already got the 0, so there's already a 0 there, so I don't have to do anything else. I just need the 0 below it. So row 1 and 2 stays the same. 1, 0, 2, 7, 0, 1, minus 3, minus 10. What do I need? I want a 0 over here. How do I get it? By adding a multiple. I'm taking row 3 and adding a multiple of that leading 1, which is in row 2. What multiple? Simply minus 1. So we're adding minus 1 to that. So we will get 0, 0, minus 4 plus 3 is minus 7 plus 3 is minus 4, and minus 22 plus 10 is minus 12. All right. Next step, leading 1 in our third column, because our second column is now sorted, which means I'm going to take my third row and multiply it with the appropriate number, and that's minus a quarter in this case, because I want a 1 there. 1 and 2 stay the same. 1, 0, 2, 7, 0, 1, minus 3, minus 10, 0, 0, and minus 4 times minus a quarter. Now I've got my leading 1. Minus 12 times minus a quarter is 3. So we have the value of our third variable is x3. I've got x3 is equal to 3. All right, now I simply need zeros above it. So I'm going to do something with row 1 and row 2 using row 3. I'm going to add a multiple of row 3 of that leading 1 to row 1 and row 2. What multiple? Row 1, I need to add minus 2 times row 3. And row 2, I need to add 3 times row 3. So let's go. Row 3 stays the same. 0, 0, 1, 3. Row 1 then becomes 1, 0, 0. 7 minus 6 is 1. Right, row 2, 0, 1, 0. I've got minus 10 plus 9 is minus 1. There we go. We are done. So x1 is 1, x2 is minus 1, and x3 is equal to 3. We have solved the system using Gauss-Jordan elimination. So what we want to do in our first column, we want a leading one and zeros below it. Then we move on to the second column, leading one and zeros above and below, and the third column's leading one and zeros above it. All right, so now let's look at an example where it's not such a pretty one, where we don't end up with a unique solution. In this case, I've got two equations in three unknowns. All right, so let's work with it and see what comes out. Augmented coefficient matrix, 1, 2, minus 1, and 12. 2, 0, 1, and 8. All right, our process stays the same. We already have our leading one there, so I don't have to go find a leading one. I can go straight to the second step. I use my leading one in row 2. I do something with row 2, add a multiple of row 1 to it so I can get a 0. What multiple? Minus 2. 1, 2, minus 1, 12. So 2 minus 2 gives me 0. 0 minus 2 times 2 is minus 4. 1 minus 2 times minus 1 is 1 plus 2, so that's 3. 8 minus 24 is minus 16. All right. Process stays the same. I've got my leading 1 and a 0 below it, so my first column is done. I move on to my second column. So in the second row, I now want a leading 1. So I'm going to use row 2 and multiply it with minus a quarter so I can have a 1 there. So row 1 stays the same. 1, 2, minus 1, 12, 0, 1, minus 3 over 4, and 4. All right. Got my leading 1. Let's get a 0 above it. So I'm doing something with row 1. I'm adding a multiple of row 2. Which multiple? Well, the number I need to turn that into a 0. So it's minus 2 times row 2. So that gives me row 2 stays the same. 0, 1, minus 3 over 4, and 4. And row 1 is then 1, 0, minus 2, plus minus 2, so times 3 over minus 3 over 4, so it's plus 6 over 4, minus 1 gives me a half. And here I've got minus 8, 12 minus 8 gives me 4. All right, I've got my second column sorted out. Now we'll move onto my third column, but I've run out of rows. I don't have another row here to create a leading 1 over here. There's no more information. That's all I've got. All right, so let's see what to do with this kind of information. If I've got it in this format, I'm going to write it as equations again because we're familiar with using equations, and let's see what this means. x1 plus a half x3 is equal to 4, if I had to write that first row as an equation. My second row, 0x1, x2 minus 3 over 4, x3 is equal to 4. All right, and I've got no more information, so that's all I have. So what we now notice, I've got a leading 1 for x1 and x2, but not x3. So we call x3 our free variable. So we say, all right, let x3 be equal to some real number t. So I've got some real number t being x3. So with the information I'm given in these two equations means I can calculate x1 and x2 by choosing x3. So x3 is my free variable. So what I'm going to get, if x3 is t, then x1 is going to be 4 minus a half t. And x2 is going to be 4 plus 3 over 4t. So you'll notice that we can generate an infinite number of solutions for this system. So here I've got an example of a system with an infinite number of solutions. So we see how many leading ones there are. I've only got 2 leading ones, which means there's 1 free variable. So my solution set I can just get from the information I have here. So x1 and x2 is given in terms of x3, which is then my free variable. In the next video, we're going to look at different types of solution sets when I'm doing Gauss-Jordan if it doesn't work out nicely with a unique solution. So here's one example of an infinite number of solutions. We will look at other types of solutions in the next video.